So today in this video we will start exercise 6.2. Okay, so before starting exercise 6.2 we have to discuss our first theorem of this chapter, that is known as basic proportionality theorem. Okay, this is first theorem which we will get in your page number 149. This is known as what? Theorem 6.1 is given as, which its name is what? Basic proportionality theorem. Basic proportionality theorem. One more name is there, that is known as what? Thales Theorem. Okay, basic proportionality theorem or what? Thales Theorem. Okay, basic proportionality theorem or Thales theorem. So directly question may come, prove the basic proportionality theorem in your exam, or prove the Thales theorem, or the question may come directly like this, as it is given in the book theorem 6.1. Prove that if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. So the question may come in any way. Okay, either directly they will give the name basic proportionality theorem or Thales theorem, or directly this question. Prove that if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the what? Same ratio. So let us start the proof. Okay, I am starting the proof. Solution. Let us draw the diagram at first. If a line is drawn parallel to one side of a triangle, so let us first draw the triangle. Okay, so this is the triangle. This is the triangle. Say triangle A, B and C. Now again read the question. If a line is drawn, okay, about a line it is saying, if a line is drawn parallel to one side of a triangle, mane one line has been drawn to parallel one side of a triangle. So we will draw a line. Say this is the side that we will consider. So we will draw a line parallel to this side. If a line is drawn parallel to one side of a triangle, okay, let me draw this line little bit below. Say over here, if a line is drawn parallel to one side of a triangle, say this is that line. Okay, understood? To intersect the other two sides in distinct points, this is the one side. If a line is drawn parallel to one side of a triangle, to intersect the other two sides, this is the other two sides, AB and AC. Okay, this is the other two sides. To intersect the other two sides in distinct points. So these are the distinct points, say D and E. To intersect the other two sides in distinct points D and E, say for example. Then what is given? This is your proof part. Okay, this line you have to prove. The other two sides are divided in the same ratio. There is a small comma, you see. After that, whatever it is written, this is the part that we will prove now. Okay, this is the given part. Whatever we have read just before the comma, that is the given part of the question. That if a line is drawn parallel to one side of a triangle, that means this is given that this line is parallel to this line. Okay, to intersect other two sides in distinct points, that means it is given D and E. Say we have considered it D and E. Now this is the part what we have to prove. The other two sides are divided in the same ratio. That part you have to prove. Means what? What that line means? The other two sides are divided in the same ratio. Means these two sides are divided in the what? Same ratio. That means this side AD by DB, I can say AD by DB will be equal to what? AE by EC. This was my other two sides. So AD by DB ratio na. So divide will come. AD by DB will be equal to what? AE by what? EC. So this part I have to prove. Okay, so let me write the given part. What is given? In triangle ABC, what is given? DE is parallel to BC. This is directly given in the question, that if a line is drawn parallel to one side of a triangle. Okay, this part is given. Now, what we have to prove? To prove what you have to prove? That the other two sides are divided in the same ratio. That means that this, if you consider this side AB side, then AD by DB will be equal to, and if we consider this AC side, then it will become AE by what? EC. AE by EC. Understood? This is what we have to prove. So to prove this, we will take the help of few construction. Okay, so what will be our construction? At first, we will draw a perpendicular from the point D. Okay, to the side what? A. This one we will draw like this. Understood? Then next, what? Another one. From this point we will draw another one, what? From the point E, another perpendicular. These all are what? These all are perpendiculars. Okay, all are perpendiculars. Say this is N, and say this is what? M. Okay, in the book also it is given as N and M only. Okay, so what is the other construction? The other construction is, we will join this BE and we will join this C. There is one more way to do this proof. Okay, there is one shortcut of this proof that I will teach afterwards. Say in exercise 6.3 I will teach that. Okay, one shortcut of this proof. In case of emergency, if you forget this proof in the exam, then there is one short method to do that. Okay, but not now. Now let us follow the way how it is given in the book. Okay, so this is the construction. We have drawn a perpendicular from D to AE. Similarly, we have drawn one perpendicular from E to AD. Okay, see, from E we have drawn to AD. Then we have joined what? CD, and we have joined what? DE. Okay, so we will write this construction part over here. Construction what you have done at first? DM, okay, DM perpendicular to what? AE. Okay, this one we have done. And next what? EN perpendicular to what? AD is drawn. This one we have done at first. Okay, and what we have done next? We have joined. Okay, this is joining. Okay, B point is there, E point is there, both the points are there, and we have joined the line. This will be joined. Over here you see D point is there, but M point was not there, so that's why we have written what? Drawn. That will not be joining. Okay, joining happens when two points are there. So there two points are there, B and E. So we will write, and BE and CD are what? This will be joined. Okay, not drawn. Understood? Okay, so this is the construction. Now we will start the proof. Okay, so let us see proof. So at first you see, we will consider this triangle. Okay, so before starting the proof, one thing I will discuss. Okay, I am discussing over here only about the heights of a triangle. Okay, what can be the, what type of heights are there? You see, say this is a triangle, an acute angle triangle I am considering. Okay, same triangle I am drawing 3 times. Say ABC. This concept will be required in this question. Okay, and I know there are many students like that who don't know this concept. So what I will ask now, say you have to draw a height from the vertex A. From the vertex A you have to draw a height. So it is very simple. You will say this is the height, straight 90 degree. This is the altitude. Okay, done. Very simple. Now I am saying, okay, same triangle, you draw a height from B. I can draw it like this also, but say I am drawing in a separate triangle. This will be the height, right? I can draw in the same triangle also, like this. It's for just for clarity I am drawing it in a separate diagram. Okay, so this is the height. Very simple. Now in this triangle, say from C, So this is the 90 degree. Okay. So very simple. These are the heights of a triangle which are lying inside the triangle. Now say I am drawing another triangle. This time an obtuse angle triangle. Okay. So say this is the triangle, and say this is the triangle. Two triangles I am drawing this time. Same triangles. Okay. Again say ABC and say ABC. Okay. So at first I am saying draw a height from B. Okay. So very simple. This is the height. Okay. Very simple. 90 degree. This is the height. Okay. Now I am saying draw a height from A. Okay. Draw a height from A. Now can you draw the height like this inside? Just you think, will this be a 90 degree ever? Will this is this look like a 90 degree? This one, say AM. Does AM is your height of that triangle? No, because this is not 90 degree. Okay, height will be exactly what? Straight. So the height will be how? This will be the height. This will be the height of the triangle. Okay, not this one. This one will not be the height. This will be the height of the triangle, say AM. That means outside the triangle. So what my point is, that height may lie outside the triangle if the triangle is what? An obtuse angle triangle. Okay, so it may not be inside the triangle always. So in this diagram this concept is required. Okay, understood? What is the main point? That height may lie outside the triangle if the triangle is obtuse angle triangle. Okay, now let us see. Let us start the proof. At first, consider this triangle ADE, the smaller triangle. Okay, this triangle ADE. In this triangle, we will find the area of this triangle. Okay, area of triangle ADE. So I will write proof. Area, we can write in shorter way also. This is the shortcut to write AR, or you can write in small letter also. Area of triangle what? Area of triangle ADE. In short, area of triangle ADE will be equal to what? So you see, consider a base. For example, I will consider this base AD. If I consider AD as my base, so what will be my height? Height always lies opposite to the base, right? Or from that vertex, the height will be opposite to the opposite side. So if AD is the base, what will be the height? This is the base, so height will be like this. Okay, if this is the base, this is the height. If this is the base, this is the height. And if this is the base, like this, it will be the height, right? From the opposite vertex. So if AD is the base, so this will be the height EN. If AD is the base, then EN will be your height. Okay, understood? You see the diagram, you draw the diagram in your notebook, or else you see the diagram in the book and try to understand. If AD is the base, okay, if this AD is the base, then height will be what? 90 degree. This will be the height, right? So what is the height? EN, right? So what is the formula of area of the triangle? If you have base and height, so the formula is what? Half into base. I am considering my base as what? AD. Okay, so AD into height. What will be the height? EN. Understood? Half into base into height. Done. This I will give as what? My equation 1. Done. Again, okay. Again, what I will write? Again, I will write area of triangle ADE. Area of triangle ADE equal to. So it will be again half into base into height, but this time I will consider a different base. What will be my base? This time in this triangle ADE, same triangle, okay, same triangle, but this time I will consider my base as what? AE. This time my base will be what? AE. So you see, this is my base. So what will be my height? This will be my height, right? This will be my height. DM, right? DM will be my height. So in the same triangle, if I consider AE as my base, so my height will be what? My height will be DM. Very simple. This will be my what? This will be my equation 2. Done. Okay, for the same triangle, we have got 2 formulas for area. This will be the area of a same triangle will be same only, okay, but only different base and different height. The area will be same because the triangle is same. Now, again, okay, now you see, again, Now you see this part. Now I will consider a different triangle. Okay, which triangle? I will consider the triangle B, D and E. This triangle, okay, B, D, E. Look carefully in the diagram. I will consider this triangle now, B, D, E. Okay, complete triangle, this triangle, okay, B, D, E. After that, I will consider the triangle C, D, E. This upper portion triangle, okay, not the lower portion triangle, B, D, C, not B, D, C, okay, not the downward one, upper one, B, D, E, okay. So, same way, I will write what? I will write area of triangle what? B, D, E will be equal to again half into what is the base and what is the height. So at first you see height. Now you know if there is a height, there will be a 90 degree. Search for 90 degree. Where? In the inside of this triangle BDE, is there any height inside? There is no height because it is an obtuse angle triangle. Okay. So where is this height? See, this is the triangle. Okay. This is the triangle. This is B, this is D, and this is E. This is the triangle. See, if you are looking the height is there. The height is there. This is the height E and N. This is B, this is DE. So you see in the triangle BDE, this is the height EN. So what will be the base? Now don't say the base as BN. Okay, the base will be BD only in the triangle itself. So what is the height of this triangle? EN, outside the triangle. That's why I have discussed that part. Okay, this is an obtuse angle triangle. Okay, you will not find any height inside the triangle. Understood? So what is the base? Okay, at first what is the height? The height is what? EN. Say half into height into base. So what is the height? The height is EN. And with respect to EN, say this is the EN. So what will be the base? This will be the base. But we cannot say BN. Okay, we will have to say the base as what? BD only. Okay, BD ko bolenge. Okay, so BD. Understood? Say this I will give as equation what? Equation 3. And lastly, what I will find? Area of triangle. Again, another upper portion triangle is what? CDE. CDE. Now this one is very clear to you, I guess, that what is the height from the point D. You see, from the vertex D outside, DM is the height. DM is the height. So for DM, what will be the base? This side, EC. Okay, only this EC. You cannot consider CM. Okay, EC will be what? Your base. Or you can say C or EC. EC. So this is equation what? 4. Done. We have got all our side. Now what to do? Now what to do? Don't memorize this part. Simply you check your two proof section. Okay, what have I wrote in the two proof section? I have wrote AD by DB. Okay, over here I am writing this one. What I have wrote over there, that AD by DB is equal to AE by DC. This one I have to prove, right? This one we have to prove in this theorem. What I need? AD by DB. Numerator AD, denominator DB. Okay. So where is AD? You find it first. No need to memorize this part. Okay. Where is AD? This is AD in equation 1. So means equation 1 will be at top. Where is DB? DB. This is DB. I have written as BD. Okay. Okay. If you want, you can write DB also, or you keep it as BD only. Okay. This is DB. DB, BD, same thing. Okay. So this will equation 3 will be at denominator, right? So now what I have to do? If I need AD by DB, I have to do what? Now 1 divided by 2. No need to memorize. Okay, in your exam you can write this one at first, this one at down also. It may happen. Okay, and if you memorize 1 divided by 3, it will be wrong. So simply just see your two proof section. What you have to prove? You have to prove AD divided by BD. So AD means 1, BD means 3. In your exam your BD may stay in equation 4 also. So this will be 1 divided by 4 then. Okay, or your AD may stay over here also. If by chance you have written this one at first, it can happen. So that time it will become 2 divided by 3. So don't memorize, just you see where is your AD. It is in equation 1. and your BD is in equation what? 3. Okay, so this will be what? AD by BD means 1 divided by 3. Now if I do this part means what? What is the left part? Area of triangle ADE. In equation 1, what is the left part? It is area of triangle ADE, right? This will be equal to say I'm writing like this, half into what? AD into what? EN. Done. This is equation 1 divided by what? Divided by equation 3, not 2, sorry, this will be 3. Okay, divided by equation 3. What is equation 3? Left part, area of triangle BDE. This will be equal to what? Half into EN into BD, or say DB, whatever you want to write, right? Okay, so now if you solve this one, you will see. Okay, for next you see what I need? AE by EC. Where is AE? In equation 2, and in equation 4 what is there? EC. So if I do 2 divided by 4, I will get what? I will get AE by EC. Clear? Okay, so I'm going to solve this one now. So this will become what? If I solve, which implies area of triangle ADE divided by area of triangle BDE will be equal to half cancel. Okay, half cancel, EN cancel, it will always cancel. What will remain? This AD by BD. Okay, I am writing now AD by say DB only. Okay, DB, not BD, I am writing DB. So this one I will give as equation 5. Okay, equation 5, I have got one part. Okay, I have got AD by BD. Now similarly, how I will get AE by EC? By dividing equation 2 and 4. So I will write now by again what I have to do? 2 divided by what? 4. So what I will get over here? Area of triangle what will say this one? ADE divided by will be equal to, so what was area of triangle ADE? I need AE, right? So it was half into DM into what? AE, right? Divided by what? Equation 4. What is equation 4? Area of triangle CDE is equal to what? Half into DM into EC. Half into DM into what? EC. Done. This is our what? Equation 4. Equation 2 divided by equation 4. Similarly, half will cancel over here. DM will cancel. What will remain? What will remain for us? Let me write B once again. Okay. So what will remain? Which implies area of triangle ADE divided by area of triangle CDE will be equal to, what is remain? AE by EC. AE by EC. Understood? So this is my equation 6. Okay. So see, I have got AD by DB also, and I have got AE by EC also. What is my last part? I have to make these two part equal. When these two part will be equal? If this two part is equal. Okay. Area of triangle ADE. I have to make these two part equal. When this two part will be equal? If this two part is equal, mane if the right part will be equal, when the left part will be equal. So in the left part, you see, in the left part, this is area of triangle ADE. This is also area of triangle ADE. That means these two part is also equal. Numerator and denominator, numerator and this numerator is same. If I have to make this thing, that is AD by BD is equal to AE by EC, pay attention. If I have to make AD by BD is equal to AE by EC, means this right part, if I have to make equal, so my left part must be equal. Very simple. Now in this left part, this numerator area of triangle ADE, and over here also in this numerator area of triangle ADE. That means these numerators are same. So my only objective that what I have to make same is what? Area of triangle CDE and area of triangle BDE. Okay, area of triangle ADE, area of triangle CDE. This is what I have to make same now. Okay, so I can now write they are exactly same. Why they are same? In class 9 you have got a theorem that triangles in the same base and between the same parallels are what? Have equal area. So you see area of triangle CDE. You see the triangle CDE, okay, in the diagram. You see this is CDE. I'm drawing, okay. So this is C, and somewhat like this. It is what? It is CDE. Now look BDE. Triangle what? Triangle BDE. This is B. This is B. This is D, and this is E. Now you see, and this one is there, okay, and this one I'm just drawing dotted line, okay. This BC. So you see these two triangles are lying in the same base, what? DE. DE is the common base of these two triangles, and between the what? Parallels or not? In the given part, what we have written that DE is parallel to what? BC. So this triangle CDE and triangle BDE is lying in the common base, what? DE, and between the parallels, what? DE and what? BC. So our theorem was what in class 9? That if two triangles are lying between the same base and between the same parallels, then their area will be what? Equal. Understood? So now what we will say, directly we will use that theorem over here. We know that I'm going to write we know that, directly I will write now triangle CDE and triangle what? BDE. Now triangle CDE and triangle BDE. Now triangle CDE and triangle BDE are lying in the same base. What is the same base? Which is the base common? From here also you can say what? DE and DE. Okay, so they are lying in the same base, what? DE, and between the parallels, what is the parallels? DE and BC. DE parallel to what? And between the parallels DE and BC, right? Not DE parallel BC, DE and BC. So therefore what will happen? So therefore we can say, therefore area of triangle CDE will be equal to what? Area of triangle BDE. This will be equal. This will be our equation what? 7. Now you see nicely, okay? Understood? So if two triangles are lying between the same base, what is the base in this question? DE is the same base, common base, okay? And if between the parallels, same parallels, that is what? DE and BC. So they are lying between these two parallels also, okay? So their area will be equal. This was the theorem. So by that theorem, I have said what? Area of triangle, this triangle and this triangle, their area will be what? Their area will be same. And our theorem is also done. Why? If I have to show these two equal, I have to first make this left part equal. In this left part also, my numerator and this numerator is already same. I have told ADE is exactly same area, same triangle, same area. So my only point was what? CDE and BDE. So now by this theorem, I have shown what? CDE and BDE is what? Exactly same. So if CDE and BDE is same, ADE and ADE will always be same. So if completely left part is same, so completely right part will also be what? Same only. So now just one line we will write from okay, this one I am running now, from from 5, 6 and this one 7, From 5, 6 and 7 we have what? Our this one AD by DB will be equal to what? AE by EC. So this is our what? Thales theorem. Very very important for your examination. Very very simple. Just remember the construction, what construction are there. Okay. After that construction, you have to find what? The area of the triangles. So at first, the area of this triangle ADE. Again, you find the area of the triangle ADE by considering different bases. Okay. First the base will be AD, then the base will be AE. First the base will be AD, then the base will be what? AE. Then you have to consider this triangle, upper triangle. Okay. So you find the area of these two triangles. Then you look what is there, AD by DB. So in that manner only you divide equation 1 by 3 or equation 1 by 4 or equation 2 by 3, whatever it will stay in your while you will write in your answer sheet. Okay. So you divide in that way. After dividing, you will get that equation 5 and 6. So the last step will be what? You have to match the area of this CDE and what? BDE, because ADE will match. Okay. So you once match these two triangles by the theorem that we have got in class 9. After doing that, you will get this answer. There is one more short method to do that. That is by the help of similarity. We will discuss it in some other class. Actually, when I will complete 6.3, then I will discuss, okay, that method. Or while doing 6.3, then I will discuss that method, how to prove basic proportionality theorem in more easier way. We will just do the similarity property. Okay, we will make the triangle similar and we will get the answer. But that is a little bit short. It is better in the exam if you do by this method which is given in the book. Okay. Okay, so this was the basic proportionality theorem. Let us start 6.3 and just discuss one question. So not 6.3, 6.2, sorry. So let us see first question. Okay. And if there is any doubt still with the theorem, you can ask. Okay. If there is anything to ask. Okay. So now exercise 6.2, first question you see. In the figure 6.17, number 1 and number 2. So number 1 I will do, number 2 you will do by yourself. Okay. So what is given? In both the diagram, DE is parallel to BC. Find EC in number 1 and AD in number 2. So your homework part is what? AD in number 2. Okay. So I am drawing the first diagram. That is what? ABC is there and DE is parallel to BC. Okay. Simple question. Very very simple question. Sometimes this kind of easy question also comes in the exam. So this is ABC. And what is given? DE is parallel to BC. Okay. Like this it is given. DE is what? Parallel to what? BC. So parallel is given. Okay. So that means we will use what? Thales theorem in there, or basic proportionality theorem. What is given? DE is given as how much? 1.5 and BD is given as 3. This one is given as how much? 1.5. This one is given as how much? 3. Okay. That one is given as 1. Okay, 1 centimeter. All are given in centimeter. Okay. We have to find what? EC. We have to find EC. Okay. So solution number 1. Okay, number 1. Question number 1. Solution. Given you write. The most important thing what is given? That DE is parallel to what? DE is parallel to BC. This is the most important thing which is given. Okay. And what is given? The value of AD is given. What is AD? AD is equal to 1.5 centimeter. Then what is given? DB. DB is given as 3 centimeter. AE. AE is given as 1 centimeter. And then EC that we have to find, which is not given. Okay. So now since DE is parallel to BC, so therefore what I can write? I can write that AD by DB will be equal to what? AE by EC. By what? By Thales theorem. Or you can write by basic proportionality theorem. By Thales theorem. Understood? That's how you have done. If in the triangle, if a line is parallel to one side of a triangle, then the other two sides are what? Proportional. Okay. Done. So in this triangle, D is parallel to BC. So other two sides will be proportional. That is AD by DB will be equal to AE by AC. Okay, you can write like this also. Okay. See, if I start from AD by DB, if I come like this, AD by DB, then you have to come like this only, okay, AE by EC. You cannot go like that. And if you write like this, you can write like this also, the BD by DA, okay, BD by DA. You can write totally correct, but then in that side also you have to write what? CE by EA. So no problem in that. It is not that you have to start always from A only or the top side only, but the most important thing is what? If you write from that side, so you have to write from that side only, okay? And if you write from down to up, then from down to up only, okay? So if it is clear, then just put the value and you will get this answer. What is the value of AD? The value of AD is what? 1.5. The value of DB is what? 3. The value of AE is 1, and EC we will find, okay? So just cross multiply them and you will get the answer. Cross multiply them, which implies that will become what? 1.5 into EC will be equal to what? 3 into 1. 3 1 is what? 3. So which implies EC will be equal to 3 1 is what? 3. And 1.5 is multiplying over this side, multiplied, so that side will be what? Divide 1.5. So now what I can do, EC will be equal to, point is there, right? Before how much? Before 1 decimal place, right? So I can multiply what? I will multiply by what? 10. In numerator also, and if you multiply in denominator, then you have to multiply in numerator also, okay? So I have multiplied both numerator and denominator by 10. So what I will get? I will get, which implies EC will be equal to 3 10 are 30, and 1.5 into 10 will be what? 15. Okay, you will know, point will go that side. Since I have multiplied by 10, so it will stay what? 15, okay? So what is 15? 15 1 is 15, and 15 2 is what? 30. 15 1 is 15, 15 2 is 30. So therefore, what is the value of EC? The value of AC is 2 cm. Same way you find number 2, okay? Same way you have to find number 2, you have to find what? AD. Same way you cross multiply that also, you will get that answer. Understood? You have to apply Thales Theorem only. Why? Because in that question also DE is parallel to what? BC. So the other two sides will be proportional. That is AD by DB will be equal to AE by EC. Or you can write like that also. BD by DA will be equal to CE by EA. That is also correct, okay? So you do that one. In this video we will stop here, okay? After that we will continue from question number 2, okay? So thank you.